students, today also I am doing another episode from our quick question series. In the morning, you can hear the sound of morning, right? Start in the morning. You can study whatever time it is. Some people are morning people, some people are evening people, some people are night people. Whatever it is, whatever works for you, start studying. Right, students? So today also we are giving quick questions to you. Actually, these questions are not that easy. I mean, you have to work on, you have to practice, you have to try these questions, you have to work on with a paper. Most questions. These are not rapid fire questions. Remember that. But I have started a series doing questions, 10 to 15 questions together. Like you have to try one question after the other. So you will learn something from first question and you have to bring that to the next question, and likewise, right? So start trying these questions. These are practice questions. Remember that when we practice questions, practice theories, actually what we have to do is we have to try similar type questions, then only we'll understand the theories, right? So but actually in the real world, when you are doing past papers or the model papers, you have to do different types of questions. You get mechanics question first, then you go current, electricity, electronics, and then you go to meta radiation questions. Likewise, you have to change it. That's the real exam, right? So don't just mix up with the other one. So this is what we are doing for practice. So let's go through the questions now.
Alright students, moving into our very first question. Seems like this question is not that easy, quick question. But actually if you want to practice questions with prisms or refraction and all that, you have to keep practicing this sort of questions. So you have an option. Right, let's look into the question now. A ray of light incident on AB surface, okay, theta, refract inside the prism and emerge along AC surface. Critical angle for AR glass common surface C, which of the following is true? Right. So basically, critical angle effect. So this should be critical angle C, right? For sure. So there's a connection between this prism angle and of course this 60. We know A prism angle equals R1 plus R2. Hope you know what is R1 and R2. So here R1 is this angle and R2 is this angle. Basically R1 plus C equals A. So here in the answers they have given sine theta value. So we have to consider sine theta value. So here let's write it again. Now we can write 60 equal to R1 plus C. So R1 equals 60 minus C. So let's apply refraction here. Sine I over sine R through this refraction. So it's basically I can write as sine theta, incident angle, sine R, right? That's this one we found here. Sine 60 minus C, of course we can see it in answers, and that should be equal to N2 over N1, second medium divided by first medium. So this is the second medium, right? This is the second medium, this is the second medium, and this is the first medium, right? So it's N2. What's N2? We don't know the value, right? Of course, N2 divided by 1, right? So we can subject and sine theta from this, but of course we have a problem. We don't know N2 value, refractive index we don't know, right? We can find the refractive index by using the critical angle, right? So let's write that equation then. So this is the critical angle equation. N2 N1 equals sine C, right? We have the value of sine C. So when it goes, if this is C and this is 90, so sine C over sine R is 1 equals N2. This is the second medium now. AR is the second medium and this is the first medium. So it's 1 over N, right? Then N equals 1 over sine C. So for N we can apply 1 over sine C in our equation. So let's get to the equation now. Now we can write it like this. Let's subject sine theta. Sine theta equals n2 into sine 60 minus c. From here we have found it's n equals 1 over sine c. So sine 60 minus c, n equals 1 over sine c, so we have to write sine c here. This is sine theta, not that hard. So sine theta equals sine 60 minus c over sine c. Do we have an answer? Yes, it's the fourth answer, right? Alright students, moving into the second question. A ray of light X incident at the surface AB of a prism of prism angle A. Right, hope you can see A. Prism angle A is emerging along surface AC. Okay, if the portion shaded is removed, this part is removed. Okay, the sign of angle of emergence will be, so what basically happen, it goes like this now here, right? So if I draw it here again, so it would be something like this. Now it goes like this. So angle of this angle is A by 2, right? That's A by 2. Here we have 90. So if you put it like this, this is 90 minus A by 2, right? Yeah. So this basically A by 2 again. Incident angle is A by 2, right? And we don't know the angle of refraction, of course. We don't know this. So they're asking angle of emergence, right? So let's write the normal equation. N2 N1 equals, right? N2 over N1 equals sin I over sin R, right? Actually, we don't know N, right? We don't have the answer even in it. So from the given data, we have to find it. A ray of light X incident at the surface AB of a prism of prism angle A is emerging along the surface AC. Just like the previous question, they are talking about the critical angle. So it goes along C. So we have to apply the same equation. So N2, same equation, and 1 over N equals sine C. I hope remember the calculations we did previously. Same calculation, so N equals sine C, right? So then we have the value N, right? Let's see, again I'm applying for this. So N2, this is N1 and this is N2 in this example. So N2 is 1, right? So it's 1 over N equals sine I is sine A over 2 divided by sine R. That's what we need to find. Okay, so sine R equals sine A over 2 divided by A over 2 into N. So we have found N as 1 over sine C, sir, you can see. So sine A over 2 divided by sine C. Sine A over 2 divided by, we don't have sines, even sine C is not given. Okay. So this value it's A by 2. So this angle is, how do you find it? This is how we find it. This angle, it's 90 here, right? And this angle, it's A, right? So this angle, it has to be 90 minus A. So then the angle C, it is A, right? Yeah, this angle C. Sine C is equal to A. So it has to be A here, right? Sine A. Sine A by 2 divided by sine A, right? This is the answer, first one. Right, students, moving into our third question. Alright, the ray of light are due to light source symmetrically on the surface AB of rectangular glass block of thickness T. The angle between the two rays is alpha. Here it's alpha. The angle between the emergent rays to CD is, right? Let's do the question now. I hope you have to try this question first. Remember, right? I hope you are doing the question. You do the question and then check the answers, right? Okay. So I'm getting to the solving the question. So first, actually, what you have to do is you have to try the question first. Try the question first. Okay. Right, when doing questions like that, let's draw the normal here. So this is the normal line, and let's draw the graph then. Not the graph but the line, right? So this is the angle now, right? Incident angle. So refracted angle should be smaller, so it should go like this, and then again we should draw the normal. And remember, when it's going through two parallel lines, the incident ray and the emerge ray should be parallel to each other. Remember, these two should be parallel. So it goes like this, should be parallel to each other. That means the angle, see, this angle should be equal to this angle, right? Yeah, angles must be equal. So this is alpha. Okay, that's the theory. Let's do the same thing here then. So it goes like this. Angle, it has to be alpha. Again alpha. So once we added these, when we add these two, see what actually happens. So this is alpha, right? This angle is alpha and this angle is alpha. So again, this angle is alpha, this angle is alpha. The angle between the rays, that becomes 2 alpha. Alright students, moving into the fourth answer. Again, I'm telling you guys, try the question first and then go through the video explanation and then find the answer. Right. Let's try it now. Up. They are telling a parallel beam of laser is incident on a sphere made of transparent material. A point image is formed at P. So this will go up to this point, right? Goes like this, right? They're asking us to find the refractive index N. Refraction, these are normal actually, right? So if we know this angle and if we know this angle, should be equal to this radius. Of course, if this is the center, it's equal to this angle, right? How do we find the angle now? Right. Yes, if we apply this equation, n2 over n1 equals sine I over sine R equation. So this is the second medium, this is the first medium, right? So it's basically n equals sine 60 over sine R. We have the R value and we have the answer. So how do you find the R value? That's the question we have here, this R value. So we can write it like this. If this is 60, here it's 60, right? Here it's 60. If it's 60, it's 120 here. These two angles are equal, right? So if this 120, the addition of these two should be equal to 60. So basically this is 30, this is 30. That means R is 30. So we have the answer now. So it's sine 60 over sine 30. Sine 60 is root 3 over 2 and sine 30 is half. That means 2 goes off, 2 and 2 cancel off, it root 3. It's 1.7. Fourth answer. Moving into the fifth question. Half of a vessel having depth 2d is filled with a liquid of refractive index N1, and the other half of the vessel is filled with another liquid of refractive index N. So it's two different liquids. We have to take them as two different liquids. So first one is N1 and the second one is N2. Right. When the vessel is observed above the topmost liquid surface here, the apparent depth of the vessel is, right, apparent depth, right? For that actually half of the vessel depth, 2d is the depth, right? So it's d here. So apparent depth, so we cannot directly apply apparent depth. N2 of N1 equals apparent depth over real depth. That's the first equation that comes into our head, but actually we cannot apply that equation. It's because two different materials. So what we have to do is we have to apply the other equation. It's the apparent shift equation. Apparent shift equals thickness of the medium into 1 minus n2 over n1. From this equation actually you can find the apparent shift of first medium and then the second medium. We add these two and we subtract it from 2D, we get the answer, right? So we have to do some work. So let's apply our equations now. First one here, d, the thickness of the medium is d, so d into 1 minus, second medium is, we can take it as always the medium of I, so it's 1, so it's 1 over n1, and the shift of second medium, it's again d into 1 minus 1 over n2. So we have two shifts, so basically 2d minus d into 1 minus 1 over n1, again minus d into 1 minus 1 over n2. So let's simplify this now. So it's 2d minus d and minus d, so it's minus 2d plus 1 over n1 plus 1 over n2. 2d cancel off, so this is the answer we are getting. 1 point missing, actually d is here, right? D is common, d over ds, right? Let's look at the answers we have. It's d, yeah, third answer, right? That's the third answer we have. This is the answer, right? Moving into the sixth question. Actually it's an easy question, I'm just giving you just to warm up. A ray of light passing through the air deviates 15 degrees in a liquid. The angle of incidence of the ray is 60. The refractive index of the liquid is. So basically you should remember that the liquid, actually we can take it as it deviates inside towards the normal, so it should be 60 minus 15, it should be 45. That of course you can take it outside, but when it comes to a air to liquid situation, you should remember the liquid should be the rare medium, right? So it's 45. We can apply the normal equation we apply, n2 n1 equals sin I over sin R. n2 is the second medium, this is the second medium, this is the first medium. So refractive index of the liquid is n at 1, sin I, sin 60 and sin 45. Sin 60 root 3 over 2, sin 45 1 over root 2, so root 2 goes up, 2 cancel, we get root 3 over root 2, so fifth answer. Moving into our seventh question now. Right, seventh question. A diver is at 12 meter depth in water. The refractive index is 4 over 3. Right. The half vertical angle of the cone through which he can observe the space is. I hope you have done this type of questions. So the cone means, actually here what happens is that, say now the light rays that goes from here, it will go through the critical angle, right? It meets the critical angle, and after that it won't, this will go through the surface, and the other rays will not move just outside. So the same thing happens for this as well, this side as well. So that is basically a cone. So they are asking the half vertical angle of the cone. So this is the cone, half angle, alpha. That's what they're asking us from. Right. So then if you draw it nicely, you can see it's vertical. This alpha, yeah, and this C. These two are equal, right? So you should draw it properly, then only you see it. So it's easy now. So if you can find the critical angle, then you can easily find this alpha angle, right? Critical angle, n2 n1 equals sin C. The second medium is this one, first medium is this one, second medium is here. So it's 1 divided by 4 over 3 equals sin C. So it's 3 over 4, right? 3 over 4 equals sine c equal to sine alpha. So alpha equals sine inverse 3 over 4. Now the hard, it's the fourth answer. Right, students, moving into our 8th question. It's actually a bit similar to the previous question we did, the cone question. A point source of light is placed 7 centimeter depth from a water surface, right? So from a water surface, a point source of light is placed 7 centimeter depth, right? Refractive index of water is 4/3, just like the previous question, it's 4/3. An opaque cardboard plate of radius r on the water surface completely block the light emerging into the air source through water. The minimum value of r would be, just similar to the other question. If you have done that question, you know the cone is created like this because of the critical angle, right? If we so from this point onwards, there's no way light goes out of the water surface, right? So only we have to cover this one. So the radius they are looking for is this r value, right? So we have the height, of course this is c and this is c, and if we can find this tan, basically tan c is r over 7, right? So if we can find the value of c, we can find value of r. Let's try finding the value of c. So same equation we need to apply. Let's apply the equation now. N2 over N1 equals sine c. Again, second medium is this one, first medium is this one. So it's 3 over 4 equals sine c. And from that we need to find the tan c value, right? Sine c. So to find actually r, we can apply a trick here. So let's draw it like this. This hypotenuse value, it should be equal to 7 squared plus r squared root, right? So let's write sine c value. So sine c from this triangle, it's r over this value, right? R over root 7 squared plus r squared, right? That should be equal to 3 over 4. So then we do the calculation. Let's take let's square the entire equation. So from that we are getting r squared equals 7 squared plus r squared 9 over 4. Bad, right? 9 over 16. So let's do the simplification. 16 r squared equals 9 into 7 squared plus 9 r squared. Let's take 9 r squared to the other side. It's 7 r squared, right? Yeah. Let's do the simplification. Right. Can do the simplification here. So 9 r squared, 16 r, 7 r squared equals 9 into 7 squared. So r squared equals 7. We can cancel it off. 9 into 7. So r basically 3 into root 7. That's the answer. 3 into root 7. We have our answer. It's the fifth answer.
I hope you have tried all those questions now. You have learned something from it. And always remember that practice makes it permanent. So what we have to do is we have to practice something correct, something right? Again and again we have to repeat trying it, so it will become permanent. So practice, right?